This is a demonstration of the PCUI Pocket Computer Universal Interface with a new model of Casio Pocket Computer. And this one is, let's see if I can get my pencil here, the PB-700. And there's also a PB-770. And there may be other variants. I haven't really checked yet. There may be other variants that use the similar connection here. More on that later. So the Pocket Computer Universal Interface is a prototype currently, and the intent of this project is to allow vintage pocket computers such as this one and many others, which offered printer and cassette docking stations or docks or adapters, etc. They're hard to find these days. They're a little bit expensive if you can find them. Many of them may not work. And in this particular case, with this model, the printer was actually a plotter, a 4-color plotter, using the that old Alps mechanism similar to the Sharp PC-1500, the Radio Shack PC-2. And they use these small pens that run out of ink or dry up, 30 some odd years later. It is possible to refill those, and I may make a video on that in the future. I do have those pens, I do have the plotters, and there are others that make replacement parts for those plotters, but they're just difficult to work with these days. So the Pocket Computer Universal Interface, which again, this is a prototype, a lot of wires and connections hanging off of this thing. The idea here is that this provides a standard interface to printers, more modern printers, as well as file storage here on a micro SD card. So instead of a cassette recorder, or instead of using a PC or a digital recorder, the PCUI will record and load from, or save and load from micro SD. This supports quite a few models, so that's hence the name Universal, and this particular video is just outlining the latest and greatest support added for the PB-100, the Casio PB-100. So let me give you a quick demonstration here of the printer mode, the cassette saving and loading, and then discuss a little bit about how the interface packs work with all these models. So the first thing I'll show is how to save something. Again, I mentioned this can connect to an optional cassette recorder or a cassette deck, interface through, I think it was the FA10, if I'm not mistaken, was the docking station, which this would plug into and then provide the printer, the plotter, and the cassette connections to a tape recorder. In fact, it also had a micro cassette deck built into it as an option. So to save, I have a program saved in here already. I've typed it in, so I can type save and then give it a file name, and I will just put in, let's see, I'll just call it test, and then put another quote, and I'll pan over here to the PCUI, because as soon as I press enter on the Pocket Computer here, this should display that it saved test. So that test program is now in the micro SD. So to load a program, I would just simply type load. I don't really care about the file name. I'm going to load anything here. As soon as I hit load, we have a menu that comes up here. The screen flickering is due to the camera. It's not synced with the refresh rate on this. So it gives you a choice of basic or data, variables. So I'm going to choose basic, and I'll select test, which is what I just saved. And I'll pan over to the Pocket Computer because it happens pretty quickly. And you can see that it recognized the file name. It is a program, not memory or variables, and binary format, I believe is what that B is. I'm not entirely sure, but it loaded. So I can load and save fairly quickly. If you notice, the time to save and load was very fast compared to cassette. If you've ever used a cassette or a PC with a sound recording program, you have to wait for the roughly 300 baud encoding and decoding there. And because the PCUI connects directly to the bus of the pocket computers, for all but the Sharp models, so all the Casio models, they save and load much, much quicker than cassette. So let's demonstrate the printer capability here of the PCUI. So I'm going to back out of the loading screen here, and I'm going to turn on the printer mode. And now it's going to listen to the bus of the PB-700, and every time it recognizes a print sequence, it will direct that print sequence to whatever's connected to the serial port here. The PCUI also supports parallel printers. I do have one connected for testing, but in this demo, I'm going to send or direct the printer output to the serial port. And that is connected to one of these. This is a very inexpensive, used thermal receipt printer. Epson is the particular brand, and this supports a language ESCPOS, which is just another method to print graphics, custom characters, formatting, that kind of thing. But this could be a standard line printer as well. It doesn't require any special software commands to print ASCII text, which is great because these effectively, for the most part, they print standard ASCII, but they, in terms of characters, but they do have some custom characters, which I'll explain in a minute. So I have the serial port connected to this, so anything I print from here, while this is in printer mode, will come out on this printer. So for example, I have a test program in here already, and as soon as I run that test program, then we'll see some text on the printer. What I've done in this particular model is I added, I shouldn't say this model, but for all pocket computer printing, I've added a setting on the menu here to enlarge the text. So if you watched previous videos, by the time I got to this model, I was tired of looking at small text. Plus, the width of this paper is slightly wider than most of the pocket computer printers, so might as well make the text bigger so it's a little easier to read. So we can clearly see that the printout works here. And I'm currently working on some of the custom characters. I mentioned this model is unique compared to the previous models that I've added support for. The previous models, Sharp and Casio, sometimes the characters internally don't necessarily map to standard ASCII. In many cases they do, because the printer mechanism itself it requires an ASCII character to come from the pocket computer. But they all, in addition to the standard ASCII, they all support one or more characters that are custom. So for scientific notation or formulas or effectively math symbols that the pocket computer supports on its keyboard and screen and its corresponding printer, they would all be supported. So on something like this is standard ASCII, and it's got extended character pages and things like that, but it certainly doesn't speak the world of Casio or Sharp. But it does allow you to define custom characters. So you can download the bitmap for specific characters, enable the custom character code page, and then print those custom characters. So when I've put this PCUI in the printer mode, it sends the Casio PB-700 code set for all the custom characters into the printer up front. And then as it's printing, it's able to redirect and translate what the PB-700 is sending it in terms of custom characters, map it to the custom character we downloaded. While this is work in progress, I will show you really quickly what the printout looks like. So I have a second program in here. And this program is printing every character from 0 to 255. So the entire character set of the PB-700. And although I'm close to getting this, I say close, but not really. If you look, many of these custom graphing characters are working. Many of the brackets, I would say, are working. This part of the code set here, the Epson already supported. So it was just a mapping exercise. And then some of these other ones are not quite lining up. So I just have to fix a couple more in the custom character set. But the idea is, again, the plotter that came with the PB-700, or not, it didn't come with it, but that was available for this model, supports obviously all the custom characters that this pocket computer supports. So if I had any programs that printed any of those, I have to make sure that, you know, on the thermal version that those also print the same way. So that's work in progress. The other thing I would say is something as old as a line printer, like a dot matrix printer like this one. These all support the IBM Pro printer standard, emulation, etc. So they can work in a similar way where the PCUI is downloading the custom bitmaps for those custom characters, and then they print out in graphics mode here, which is seamless. So this is easier a little bit because it supports more custom characters. This only gives you, like, I think it's somewhere around 60 custom characters in the code page. So we're pushing the limit with this one, but I'll work through that. So a little bit more on, because I didn't do this in previous videos, I didn't really explain it very well. So this is a prototype, so by the time this video is published, chances are there will be the next revision board all wired up, and I'll call it pre-production ready almost. So this one is under test right now, so the debug cable is connected. I'm running, you know, some effectively the equivalent of some bodge wires to get the busy signals set up for this model. And the exercise is, after I get this working, any new wiring or connections that have to be made, or outputs and inputs are put into the next revision of the board. And then it's powered externally because this battery is completely dead. So that being said, I didn't really explain in the previous videos too well. I didn't go into too much depth here, but the pocket computer interface on the PCUI board is here. And it's a 16-pin connection. So that means we have up to 16 inputs and outputs, two of which are reserved for power and ground, so really only 14. And the idea here is I wanted to make this as inexpensive as possible. This is a standard IDC type connector. In this kit, this is going to be offered in a kit, so this will come with these connectors, but these are easily found these days. And the connectors on the back of the pocket computers or on the side are not necessarily easy to find these days. Some of them are simple, you know, 2.54 inch, you know, header spacing compatible. Something like this model is not. It uses 2 rows. I'm not going to move it too much because it's a little bit precarious here with the wiring, but it has 2 rows of pins. The bottom row offset slightly from the top row. Top row may have an even number of pins, and the bottom row has an odd number of pins. And again, you can't necessarily find that connector these days. So with this interface, the challenge has been the PCUI interface to pocket computers. The challenge has been on the other side of this cable. So the idea is every model that varies in its connection. So the other Casio, I put a video out, was on the PB-100 and the FX770. That used I think it was a 12-pin solid row connection, right? This one I mentioned is 2 rows with the bottom row slightly offset. And so there's a different interface pack. I'm referring to these as interface packs. So while this side of that cable is the same for the PB-700, the other side of the cable is not going to be the same. So I'll show an example of one of these. It's kind of an early prototype, but the idea is that you connect the standard on this side to the PCUI, and then the other side of this will vary depending on the pocket computer that you're connecting to. So I have a total of 4 different ones of these so far. And so obviously I have to make up a new one for this now that I have it working. So it's currently wired in temporary fashion to the PB-100 or FX770, the 12-pin connector. I just have it remapped so that it works here. But the idea is that there would be a dedicated version of this interface pack for this line, or these models that use the same connector here. And what's really interesting about this model is it places the data for the printer on its bus. So it's 4 bits at a time. Unlike the previous model, the PB-100, the FX770, the Casio, the PCUI had to act as more of a bus master, grab hold of the bus, go out and address the memory, and ask for the 4 bits in 2 memory locations. So it had to go fetch the data to print out of the calculator. And this model actually places the data on the bus. All we have to do is listen for it and grab it, which it's far easier to implement. Not only that, I found that Casio had released, I think it's the FA4. Again, these numbers I'm not entirely positive of because I don't own one of the FA4s myself. But it was a cassette interface with a standard parallel port on it. So you didn't have to use the plotter. Again, good luck finding one of those today's, that they're just not readily available. But in looking at the service manual for that, they implemented that parallel port connection with a series of basic logic chips. They used level converters, flip-flops, standard parts. There was no microcontroller in there. So when I saw that service manual, I said to myself, it would be really exciting to get this model working with the PCUI. So it's a lot easier. It was a lot easier than the previous one. And as a result, now I don't have to use that plotter with the 4-color pens and worrying about refilling them in the plotter paper and all that stuff. I could just print directly to a inexpensive thermal receipt printer. These you can find used, very cheap or inexpensive, and the paper is, again, widely available, no ink needed, fast printing, and you can't go wrong with that. So with the PCUI, you can use any standard line printer, serial or parallel, and then this now supports the PB-700. So excited to try some of the new things on here with the printing capability. And then on the second half of this video, there's a little bit of what you maybe call bonus footage. A new package arrived relating to the PCUI. So if you want to watch the second half, if you're interested in some behind the scenes stuff for this project, you can hang in and watch that second half of the video. And I will be offering this as a kit. So, you know, if others are interested in putting this together, I will ultimately be updating the project page. There's a link in the description for that project. That link will ultimately be updated with information on how to get a hold of the kit once it's ready. I have to make sure that the instructions are done and that I can follow the instructions, and I have to make sure that there are no future major revisions. So I'm trying to get through all of the models of pocket computers and calculators that I have access to before cutting a version of this board and releasing it. That way I get everything in there up front. All right, well, thanks for watching the first half, and the second half is a little bit of behind the scenes. All right, let's see what we have here. Call this bonus footage, I guess. This is definitely the second revision. I don't know, I've lost track. PCUI, and this is a little bit of behind the scenes how this project has been progressing. So let me get something to open this. Let's see if I can open it with my hand here. Yep. Okay, let's see what's going on. And gotta cover up the address there. So we have good paper crunching noise in there. Okay, I gotta get that open. Let's see what we have. We just do this off camera. It's got my address on it. Okay. Lots of foam. This is revision 1.2. So we had 1.0, 1.1, 1.2. Third version of the PCUI main board. And let's see what else we have. Looks like a whole bunch of other boards in here. PC8. So in one of the other videos, we got the PC8 working, which is also the PC4, Sharp 1246, and maybe the 1249, 1250, all that 11-pin models. And let's see, this is the PC6. So that's also the PB-100, a whole bunch of different Casio models here. And this I'm looking most forward looking to, most looking forward to. The FX702P. This I just posted a video on, and this one uses the Spark printer. So again, most excited to have this one working. So let's take a look at this one because it's the first revision of its kind. Do not eat. Okay, let's take a look. Okay, so this is, yep, FX702P, 602, 502. One of the things I was most nervous about, and we'll find out, this uses the 12-pin IDC header connector here. That would be soldered into, I believe, the back. No, this side. And then on the back or the front would be the spacing for the proprietary connector on the 702P. So we'll see if this lines up. I hope it does. Since I get it wrong so often, and these are prototypes, minimum orders on these. And let's see if I can check out the PC8, because again, that was a new one. The PC8, PC6, this one. More throwaway, do not eat. Okay, so this one will be similar. I'll save that. We have, let's see, this is the PC8. Did I mark this? No, PC6. It says PC8 on here. Well, I guess this will be a surprise to see what this last one is. Okay, might have made a mistake there. So this is the updated PC6, so I had to add a few caps on a few of the data lines there to solve a noise issue. So hopefully this version works better than the previous one. I had an issue just with the PB-100, one specific revision of it. All the others work just fine, so we'll see what happens there. And this says PC6. I hope it's the PC8, otherwise I'll have to wait till the next revision, and there will probably be another revision. Let's see. Ah, yes, PC8. Good. So this one is brand new. Didn't need any loading caps on this one, but I did have a whole bunch of pull-down resistors on this for unused pins. So PC8. Have to wire that up and give it a try. And then finally we have the main board. This is the third revision of this. Most notably, let's see if I can get this open without making a whole bunch of noise. Otherwise I'll have to edit that out. Let's see. There's no pull tab on this one. This will be fun. Wrapped in bubble wrap. Okay. Let's see. We don't want to use a knife on this. Let's see if I can stretch it just a little bit. Yep. Okay. Wow, it's packed pretty well. Okay. Again, minimum order. I will probably need another revision. Okay, so this one, the big change on this revision is 1.2, and so we had this connector here for, let's see, this is a TTL interface for, I had this on all prior revisions. So this is the Pocket Computer interface here, which was all at TTL level until I got to the FX702P. Found out it was CMOS level. This is a level converter here. The Pico's 3.3 volt CMOS, and so I have a bidirectional 16-bit level converter there. So I added this, which is a connection before the level converter, so we can keep it at 3.3 or CMOS level for the FX702P. So anyway, I had to add another connector, and this one I believe is 16 pin, and I made this one 12 pin so that you can't plug one into the other by accident. And that would be a bad thing to happen. So I think I got that right. This one also adds status LEDs below the display. Again, purely cosmetic there. The ideal diode change is in there, so I'm no longer using an old diode. A regular diode there with a voltage drop was too great. What other? Oh yeah, this is the, I can switch the RX and TX lines on the RS-232 port with jumpers. That is not as useful for everyday use, but for debugging, like if you wanted to connect this to a computer, you'd have to get a null modem cable to switch the pins to go from there to a printer. So I ended up just putting jumpers here so that I don't have to use that adapter. And I think that's the only, really the major revisions. There will be, unfortunately, at least one more. As I add more support for different models, I find that for whatever reason I need another status line, some sort of control signal that I didn't account for, or LEDs or something that would be useful. But yeah, this is the next version, 1.2. So I'm going to wire a couple of these up, get the instructions going. I'm going to test the instructions. I've actually put them together. But I'm going to run through it and see if I can put it together following the instructions. If I can do that, then other people can do that as well. And then I will post a video update once this version is wired up and once I get it working. And by then, I should have all of these interface packs ready to go for testing. And then, again, the next version, I'm definitely going to have to do that PB-100 connector. It's yet another interface pack. So we'll do another revision. These actually came, these PC boards, PCBs, I'm not sponsored in any way by the manufacturer at all. I paid for these, I paid for each revision. These are from PCBWay. This is done in KiCad. You zip up your project files, upload them, and then, roughly a little over a week later, they arrive. So this has been a rather seamless experience. The boards seem very high quality. This is blue as opposed to green, the standard green PCBs, but I can't really complain about the service. They turn them around pretty quickly. They do seem very high quality. Of course, time would tell. You wait about 20 or 30 years and see if this is still working. But anyhow, stay tuned for updates on the PB-700, other models, and then the result of testing the new revision. Thanks for watching.